everyone. So in this video, I'm going to talk about chain rule and how that will help us finding derivatives of some weird looking or complicated functions. Fun fact: if you go on Google right now and if you type in the word chain rule comes after chain smokers, which I think is just absurd, but whatever. So that was my little rant on the word chain. So basically, chain rule seems complicated, but basically the formula is, let's say you have some function, right? You have f of x, and it's equal to some other function. But basically, what happens now is, back when you were learning about composite functions, this will help us find the derivative of a composite function. So let's say you have some function g, and that consumes the function h of x. Okay, so it's g of h of x. If this is the case, then the derivative of x, which is f prime of x, is equal to g prime of h of x times the derivative of the function h of x, h prime of x. Right now, this all seems well and good, and sometimes I mean, I get confused if this is the only thing given to me. So the best way to do this is to go through an example. Okay, so let's say I have a pretty simple example. Let's say I have example. I have f of x is equal to x squared minus 10x, and the whole thing is squared. Okay, so if this is my case, yeah, I could sit down there and then expand this out and then go from there. But that's really not the point over here. If this was a 200, what am I gonna do now? Am I gonna sit there and do the whole product of this? So the thing is, what we do is you kind of ignore the inside function for now. By inside, I mean whatever is inside the parentheses, right? So let's just say it's instead of x squared minus 10x, let's just say, if you're starting out, okay? I mean, if you're seasoned in this, then don't do this. This is highly inefficient. But let's just say k is equal to x squared minus 10x. So wherever I see x squared minus 10x, I'm just going to replace that with k. Okay, so now this is equal to k squared. And we know how to take a derivative of a squared function, right? So what's the derivative of this function over here, k squared? Well, it will be 2 times k, take away 1 from the exponent, so that's just 1 over here, and then that's it. But now I need to replace it back with x squared minus 10. So it'll be 2 times x squared minus 10x. But that's not it, okay? If it was k, then yeah, we're done. But here we have x squared minus 10x. So what we now do is we take the derivative of x squared minus 10x as well, and tag it on for a ride on the back or here as well. So what happens now is that this turns into 2 times x squared minus 10x times the derivative of x squared minus 10x, which would be 2x minus 10. So this right here, that's our answer. Okay, so basically we treat the whole parentheses as just whatever is inside as just one function, and then we go from there. So we take the exponent, bring it down, keep the parentheses the same, and then take 1 away from the exponent. So this is a 1 over here, which is equal to 2 minus 1, right? And then we take the derivative of the inside function. Okay, so let me do another example over here. So let's say I have f of x is equal to 2x to the 6 minus 7x to the power of 18. Okay, so it's kind of a similar thing over here, just like we did over here. So the first thing that we'll do, and I'm not going to do k is equal to the inside over here. Okay, the first thing we do is bring down the 18. Keep the coefficient, which is 1 over here. So it'll be 18. Then we keep the same function, so 2x to the 6 minus 7x. Then we take away 1 from the exponent, so this is 17. And then we multiply all of this with the derivative of the inside function. Okay, the derivative of 2x to the 6 is 12x to the 5. The minus stays a minus, and the derivative of 7x is 7. So this right here is the answer. Okay, so that's pretty much what chain rule is in its entirety. And I hope you're not too intimidated by that. Yeah, it's a derivative of a composite function, but basically just treat it like any other function, okay? You take the exponent, bring it down, multiply by the coefficient, keep the function the same, take away 1 from the exponent, but the only thing you're doing now is you're taking the derivative of the inside portion as well, okay? So that's it for this video. Hope you learned a lot, and good luck, and I'll see you next time.